Namaste all. So in this particular video we are going to discuss the solution for the question asked in Electronics and Communication GATE paper of 2014, set 3 of the paper, and the subject concerned is mathematics. The question was asked for 1 marks. So let's see what the question was. The question says, if z equals to xy ln xy, then which of the following option is correct? So z is a multivariable function of 2 different variables x and y, and we need to find out which of the option given is correct here. Very clearly the option consists of partial derivatives of z, right? So the reference for the solution of this particular video is going to be any graduate level course on solution to partial differential equation or even differential equation. I'm sorry, I'll just do it right, yeah. So any graduate level course on solution to differential equations, which is studied by any student in his BTech curriculum in Bharat, and the other source can be NPTEL video on the course called Multivariable Calculus given by Professor S.K. Gupta from IIT Roorkee. In specific, you can look at lecture 5 of the course to know about the partial derivatives. The concept required to solve this particular problem would be the knowledge of partial derivative and how to calculate partial derivative of a multivariable function. Also, if you look at the options given, the very first option here indicates something about what is called as the homogeneous function and the degree of homogeneity of a function. Okay, so I'll be going in brief to define a homogeneous function and the degree of homogeneity, and then I'll also solve this particular question. So given z equals to xy ln xy, we'll try to have a partial derivative of z with respect to x first, and in doing so we know that we'll be keeping y as a constant. Okay, that's how we calculate the partial derivative. So we'll apply product rule in doing so. So when you do the derivative of xy with respect to x, you take y as a constant and you multiply the remaining term in product rule, plus you differentiate ln xy with respect to x and you multiply xy as it is. So when you differentiate ln xy with respect to x, you keep y as a constant again, and you have xy, and then you have a y at the top here, which is this. So it comes down to y ln xy, sorry for that. So it comes down to y ln xy plus y, and then you differentiate z with respect to y partially. So you have x as a constant now. So when you differentiate xy with respect to y, keeping x as a constant, you get x multiplied with the second term, which is ln xy, plus you multiply ln xy with respect to y, keeping xy as it is. So then you get 1 by xy, and then you multiply, then you differentiate xy with respect to y, you get x. So this comes down to x ln xy plus x. Now clearly it's very clear that if you multiply the first expression with x and the second expression with y, you'll have two equal things, as in xy. If you multiply the first one with x, you will get xy ln xy plus xy, and if you multiply the second one with respect, with y, what you will get is xy ln xy plus xy, correct? And clearly these two things are equal. Therefore I can say that since I multiplied this first expression with x, I can write it as x dz by dx equals y. Since I multiplied this by y, I can write y dou z by dou y. So it's actually option, if you go by the option, this is the first option given in the list of options. No, sorry, it is actually the third option, C. So option C of this particular question is correct as far as the options are concerned. But then I told you something about the homogeneous function, right? So what is it? You see, when you calculate when you have a multivariable function, say x1, x2, and all those variables are there till xm, what you do is you try to check this particular thing. If you substitute all these variables by some constant time the variable kx1, kx2, where k is something, some constant scalar xm, and you get something like this, k raised to n, the function of the same variable, then such a function is called a homogeneous function. So this function is now called a homogeneous function, and a homogeneous function. Okay, and the degree of homogeneity is n. The power of k, which comes out as common, is the degree of homogeneity. and there is a theorem for this homogeneous function, Euler's theorem, which says that if you have a homogeneous function of order n, you have n times the function itself equals to sum of multiplied with the variable times sum of the partial derivative with respect to that variable. With respect to that variable m. So this is what Euler's theorem state for any function which is a homogeneous function of order, or sorry, degree n, the degree of homogeneity n. Now you see option 1 of this particular question is that very same kind of an option, right? You have the variable times the partial derivative with respect to that variable, the variable times the partial derivative with respect to that variable, but the sum doesn't account to the n times the function. Well, the sum doesn't account to n times the function. Well, if you observe, this function actually xy ln xy is not really homogeneous, because if you substitute x with kx and y with ky, what you end up getting is k square xy. So you will have k square xy ln k square xy. So this doesn't end up being some k raised to n times the original function, okay? Because you see, you can separate this log term as this ln k square. So this term here comes out to be extra, and this doesn't allow this function to be homogeneous. Otherwise, if this would have been only term, the function would have been homogeneous with degree 2, but that's not the case. Therefore, this option becomes wrong. And secondly, even if the function would have had degree 2, the 0 would not have been here. It should have been 2 times of z, okay, or 2 times of xy ln xy, but that's again not true. So this is all about a homogeneous function. So to give you an example, if the function would only have been say x by y instead of xy ln xy, see, the function would have been x by y. In such a case, what would have happened is, if you take the derivative of x with z with respect to x, what you will get is 1 by y, and if you take the derivative of z with respect to y, what you will get is minus x by y squared. Correct. Now, very clearly, if you multiply x times dou z dou x, which will be x by y, plus y times dou z dou y, which will be minus x by y, you will get 0, and which is nothing but 0 times of z. 0 is the order of homogeneity of this particular function, because if you substitute x with kx and y with ky, you will get k raised to 0 x by y, which is the original function. So you will get k raised to 0 times z. 0 is the degree of homogeneity, therefore you multiply the degree of homogeneity with the function itself and you get a 0, which is exactly what happened when you sum up the partial derivative and multiply with the variable, okay? So this was to show you what a homogeneous function is, and why option A was not true, and in which particular case option 1 would have been true. So that's all about it. So the correct option still remains option C for this particular question, which you could have calculated just by knowing the fundamentals of how to calculate the partial derivative of a multivariable function. So option C is correct. I hope the solution was clear and you also got to know a bit about homogeneous function and the degree of homogeneity. Thank you.